Alrighty, guys. Now on to section 7.3. So up until this time, we've been building on learning how to solve quadratic equations. So now what this section is doing is, so pretty much in this section, our goal is to reduce down to what we know, which is quadratic equations. So as you can see, so I think the best way to do this is just to go dive into an example. So our directions are to solve, right? And if there's more than one solution, separate them with commas. Our first example, we want to solve for, we have y squared minus 11 quantity squared minus 10 y squared minus 11 plus 25. So if we just do this like just how it is, then you'd have to FOIL this, then you'd have to distribute this, combine like this, and then we'd have to deal with a y to the fourth. That is gross, right? But if we take a minute to notice that we have y squared minus 11 in both of these, right, and we do have squared, and then, so this has the potential of being simplified into a quadratic formula. So we're going to use substitution, right, and I'm going to say, I don't know, we can say x is equal to y squared minus 11. What happens when I plug in x wherever I see a y squared minus 11? Then, so let me fix this, should say let, right? So if I do that, then I'm left with x squared minus 10x plus 25 is equal to 0. This I know how to solve, okay? So this did make it more simple. So now what am I going to do? I'm going to solve it as if, just solve it like normal. So we have x squared minus 10x plus 25. This is kind of ringing some bells for me. This is a perfect square trinomial, okay? Because this is a perfect square, this is a perfect square, and when you multiply the 2ab, you will get negative 10x. So x squared minus 10x plus 25, this is factored into x minus 5, quantity squared, is equal to 0. So, and then I just want to emphasize, like, see how much faster that is if I know how to factor, as opposed to using the quadratic formula where you would have had to do x is equal to 10 plus or minus the square root of 10 squared minus 4, 1, 25 all over 2, right? And then simplifying that, that's gross. So I really emphasize on really knowing how to factor. So now, like we do for solving quadratic equations that we learned from section 1. Now we're going to use that property. So x minus 5 quantity squared is equal to 0. This is also x minus 5 is equal to plus or minus 0. But what is plus 0 and what's minus 0? It's just 0. So we can just take that away. Then we solve for x. So x is equal to 5. Right? So now we figured out what x is, but we are not done yet. Why? Because we want to solve for the variable y, not the variable x. Right? So now we have to substitute back what we know. So substitute it back in. So we knew that x is equal to y squared minus 11. So now we're going to replace this x for y squared minus 11 is equal to 5. And now we're going to solve. Right? So I'm actually going to bring my work up here. So I have y squared, and then I'm going to add 11 to both sides, so I get 16. Okay? I'm going to use that property, so y squared equals 16. I can say that's y is equal to plus or minus the square root of, oops, going ahead of myself. This is plus or minus the square root of 16. So therefore, and then what's the square root of 16? It is 4, because 4 squared is 16. So we get y is equal to plus or minus 4. So if we want to separate our answers in commas, we know y is equal to 4 and negative 4. And this is our solution. So when we see problems like this, and then we notice that there's some like terms, try substituting and see if it works out. Right? So now, let's do another example. Right, so this example looks a little bit different, and it is x to the fourth minus 4x squared plus 3 is equal to 0. One thing I do want to say, so even above, oops, I did not want to do that. Before we continue, when you substitute, like you should, like a good rule is to never pick the same variable you're working with. So if I said y is equal to y squared minus 11, I know that would be a different y, but if you end up with y equals 5, that's kind of misleading and saying that you're already done. Okay, so always pick, when you're substituting, always pick for a variable that you're not using, right? So when you see x equals to 5, hopefully that, and then you have a y up here, hopefully that rings some bells to say, oh, I better do something, like I have to do more, right? So now on to example 2. So this is almost what we know. So remember, we want to, our goal for these is that we want it to look like ax squared plus bx plus c is equal to 0. Okay, but over here we have x to the fourth and we have x squared, right? So maybe, let's test it out. So let's think, what if I can have y is equal to x squared? Because I want to make this a linear term. If I'm going to plug in y is equal to x squared, how would I substitute this first term? So first, before we do anything, how about let's rewrite this equation a little differently. So x to the fourth, if I use my exponent rule, so x to the fourth, that is also x to the 2 times 2, right? Because, yeah, so when we have like the power rules like this, then, yeah, then we'll still get x to the fourth. Okay. And now, this is what we know. So we want to substitute y for x squared, and as you can see, we have reduced this to an x squared, and then we even have this quantity squared up here. So now wherever I see an x squared, I'm going to plug in a y. So now I get y squared minus 4y plus 3 is equal to 0. And now this is a quadratic equation. We have reduced this to a quadratic equation. So now we're going to solve like how we normally do. So first I'm going to see, are there two numbers that multiply to be a positive 3 and add to be a negative 4? And the answer is yes. It is y minus 1, y minus 3. Right? And when we check our work, you get y squared minus 3y minus 1y, which is minus 4y, and then negative 1 times negative 3 is positive 3. Now I'm going to use the zero product property. So what does it say? It says that y minus 1 is equal to 0, or y minus 3 is equal to 0. Right? So then we get y is equal to 1 or 3. Oops, actually. Okay. However, so our goal, we want to solve for x, but these are y's. So what do we have to do to solve for x? We now have to substitute this back in. So y is equal to x squared. So let's plug in x squared is equal to 1, or x squared is equal to 3. Okay. So when we take this, when we do that square root property, we have x is equal to plus or minus the square root of 1, or x is equal to plus or minus the square root of 3. So let me bring my work up here a little bit. The square root of 1 is 1, because 1 squared is 1. So we're left with x is equal to plus or minus 1, or, and then for the square root of 3, 3 is a prime number, and it has a factor, or it has a power of 1, which is less than our index. So this square root is as simplified as possible. Right? But we want to separate our solutions with commas. So, very last step, we're just going to rewrite this off. So x is equal to, we can say minus 1, 1, negative square root of 3, square root of 3. It does not matter which order you put them in, as long as you put all 4. And this is our solution.